All right, we're up and running. Today we're looking at what section is this? 8.4, 8.5. Ooh, big time. 8.5 notes. Okay. Applications to economics. So, this is what I know. If you want to maximize profit, okay, maximize profit by forcing marginal revenue to equal marginal cost. And I'll talk a little bit about those in just a minute. But the big thing is marginal revenue to equal marginal cost will maximize profit. And we'll look at units a little bit in a minute on that too. So, why would we want to maximize profit? Money! Money makes the world go round. And I was reading about some of these big franchises like Starbucks and McDonald's that have a very uniform system. And how if they can just shave a few ounces of mass off a cup, or if they can save just a fraction of a second in the preparation of something, that, you know, company wide, that it makes an actual difference. And so both of them, both McDonald's and Starbucks, have laboratory stores where they videotape and observe people and do, some really academic studies on the activity that goes on in those stores. And then they design procedures that they send out to the gazillions of little franchises out there. Although, I don't know, is Starbucks a franchise? I can't remember. McDonald's is definitely a franchise. And by that, it means, Thomas, if you get wealthy, you can buy a McDonald's here in Independence and run it. But McDonald's, the big parent corporation, tells you what to do and what to sell and what to say and what prices to charge. But you get to keep the profit. Derek?
In my online economics stuff I was talking about market revenue and marginal cost, it was frustrating because I just felt like it wasn't making sense because didn't you want the revenue just to be as high as possible?
Oh, great question. Great question. Wouldn't you want the revenue to be just as high as possible? Okay. Um,
Because if revenue equals the cost, then you wouldn't be actually making any money.
yeah, but this isn't revenue and this isn't cost. This is the rate of change of revenue and this is the rate of change of cost. And that's an important distinction. That's an important distinction. Okay. When we say marginal revenue,
But still, wouldn't it be better if your revenue was going up faster than your cost?
would it be better if your revenue was going up faster than your cost?
Because then you'd be making more money.
Yeah, but I know what you're saying, but at the same time, okay, let's think about this in terms of sales. Okay, let's say you have some kind of a product, right? And here's the price, and here's the sales. Okay? So what happens in this kind of a situation? If I have price pretty low, what happens to sales? They typically go up. And as the price gets higher, what happens to sales? It typically goes down. Okay? And as you all know from your economics, and you guys have economics as seniors, right? To me, it seems like sales are dependent upon price. Well, that's interesting. That's really interesting.
The point is that it varies because you look at, if you're a producer looking at the number of sales and then you adjust your price accordingly.
Right.
So it's really
So the idea is to find that sweet spot where your price still allows you to be profitable, but you still get some sales. Um, so that part again, I'm not a big expert on, and we're just going to look at it from the calculus point, and hopefully you guys that have had economics can kind of put the two together and use it. Okay, so at least according to the calculus point of view, and who knows what this is, it might be more theoretical than actual. Okay, we got to do some definitions. Okay, um, the revenue. Oh, it's very real. The revenue with respect to um, X, which would be the number of units sold, I guess. Not sure how to say that. So this is a revenue function. So, how do you get revenue? You sell products, we'll call that X, and then what happens? Well, no. That's not revenue. Revenue is just one thing. You have products, a number of products, and what else do you have? Price. Okay? So we say it's X times P of X. Okay? Number of units sold, and then the price. Price per unit. Now, revenue is not profit. How much money's coming in? You're still going to have expenses. You're going to have advertising. You're going to have court costs because Johnny's suing you because he spilled coffee on his lap or whatever, right? Okay? So then profit, and I don't like their use, but this is what I see all the time. They say P of X, big P of X, profit. I wish they would have come up with a different letter, but that's what they're using. Profit. Yeah, I agree. But this is what you see all the time. Then is going to equal revenue, R of X, then what? Revenue minus cost, C of X. Good. Well, I think, well, corporations hardly ever pay taxes. God. But it is part of cost. Everything that goes into producing that unit is part of your cost. Advertising, taxes, utilities, um, income. What's the difference in income and profit? Income, isn't that like revenue?
I'm pretty sure that's profit.
Hmm.
You have before and after net
Gross income, net income. See, again, you guys may know more about that stuff than I do. Okay? Yeah. Well, and yeah, this is more like from a business perspective than I guess an accounting perspective. So then, this is where it gets really interesting. So we have our revenue here. So we'd say the first derivative of revenue is defined as the marginal revenue function. Now, and again, you guys help me out. Talk to me. What would rate of change, instantaneous rate of change of revenue represent?
how much money you make per se. Exchange, well, yeah, no, the derivative would be the amount you make per se. Because
It would be, well, let's think about it from a graphical standpoint. Okay, revenue is going to be some kind of function, right? And what are the items here? Uh, again, what's on the x-axis? Sales and price. Okay, and if we do a derivative, the slope of the tangent line at any point, it's going to be price over sales. and it's a rate of change. It's the slope of that tangent line. And exactly from a economic standpoint, what that represents.
Okay. Okay.
Additional revenue, does that work? And I'm asking a legitimate question. I'm not positive on this one.
So my economics class, he took it off.
Yeah.
Everyone else took it.
Here at school?
Nobody else actually listened to it.
Well, anyway, it is, and Derek might be full of crap, and he usually is. But in this case, that seems plausible. The change in price per sale.
Mostly a change in price per sale. It would just be it would basically be the total revenue for one additional sale. The revenue
I don't know about one additional sale. I don't like that.
but it's X for over the period of sale that you're measuring it.
Okay, I will go for that. Mister, you got a wrinkled brow. What do you think?
I think it's funny that you switched taxis for this part.
Did I switch my axes? Did I?
You go forward.
Oh, that's it. Oh, no, that's terrible. Now you got me doing it. Shouldn't it be price and sales? Now you got me doing it. We were just having that discussion. I don't know.
I honestly don't know because I would honestly say it's depending upon the price.
I think so. Will you look that up if you can? Something about marginal revenue in terms of that is so funny because we just had that discussion and then I went and did it.
I think the thing is when you're looking at economics, both the sales and price are manipulated. You can manipulate both of those because you can change the price to change the sales. But if you can, but then what the sales do, the producer can then decide that they want to change the price to.
Yeah.
So they're not in charge of prices.
Say that just a second. Say that again, Johnny. They have sales on the X? God, I don't like that. So say that again, Jeremy. The last part. Let him do it. Yeah. No, right before that. Okay. Revenue that will be increasing product sales by, I don't like 1 unit. I would say a change in units.
Except when you're dealing with microeconomics, you're selling things you don't sell half of a item.
No, true. True.
You're dealing in discrete quantities.
Okay. Well said, discrete. I like that mathy term. Okay, so marginal revenue function we had as a first derivative of the revenue function. Can you guess what the marginal cost function is?
No, I think it's the second.
No, it's just the first derivative of the cost function. Okay? So we had C of X is the cost associated with producing an item, and the first derivative is the marginal cost function. And why I got these is because remember we defined maximizing profit by forcing the marginal revenue to equal the marginal cost. And maximizing profit is a good thing. You want, well, you want your revenue to be as high as possible, but you can't just say, "Oh, I just want a bunch of money." Everyone wants that.
Yeah, but
Ideally, you want your
but if you could find a way to make technologies that makes producing your good cost less, why would you want to lower the price of your goods so that they still remain equal.
Maybe to be competitive. I mean, does this take into account competitiveness? I don't know. All right, Derek, let me stay with it, and maybe it'll come to you, uh, and maybe we can come up with a better explanation. Right now. I'm just going with what the experts are saying. You know, you could rule the world. You could be like Doctor No if you make this work. I don't know. Yeah. Okay. So we have an example here, and in the example, we're going to define revenue. We're going to take the first derivative. We're going to define a cost function, take the first derivative, set them equal to each other, and solve it, and see what happens. So, yes, it's everywhere. Where was I? Okay. Maximize profit. Profit, that's my word today. That's my Alexism today. Maximize profit for uh, Colton's Cool Company. Okay. Um, you got a given cost function of C of X equals 84 plus 1.26x minus 0.01x squared plus 0.12347x cubed. I don't know. Just um, and then price P of x equals 3.5 minus 0.01x. So these are just given. These would only be specific to Colton's company. Right. All right. So what did we say revenue was? Revenue way back in the day was X times P of X, number of units sold times the price per unit. So revenue R of X equals X number of units times the price per. What's that? Price is given, but not revenue. So here's the deal. How can we make this be revenue? How can we make this be revenue if we know price? Johnny, spew nonsense. Louder, though. Yeah, let's multiply everything times x. Why not? We can do that. We can do that. So R of x equals x times P of x equals 3.5x minus what? Yes, we can. Johnny, you said that like you felt like we were cheating or something.
I think it was more that you already had written X feedback. So it doesn't matter.
Okay, so the first derivative of that gives us what? Mm-hmm. Okay, good. So far, so good. We're going to need that. Save that for later. Okay, so far, so good. Marginal cost. So we start with, we're going to need C prime of x equals the derivative with respect to x of, well,
In the first three, because you have like your initial like cost of your factory, your house cost, and then that the minus 0.1x squared would be the k. So I don't get the.
so C prime of x equals what? What did we start with? C of x, this one, 84. Well, I think you all should hit Mr. Thistle. Is he the economics guy? Hit him with this, because I love it when anything goes between two classes, whether he math and physics or math and economics or whatever. I think hit him with this from that point of view and see if these math people are full of crap. I don't know. 0.02x plus 0.123. Where'd we leave off? Oh, there it is. Finish it out, guys. 21 x squared. Good. Good. Okay. So then, if we want to maximize profit, that's the second part. Maximize profit. Profit. Where's my mass? Maximize profit where exactly where they intersect, where r prime of x equals c prime of x. Oh, I went too far. So that's 3.5 minus 0.02x equals 1.26 minus 0.02x plus 0.00021x squared. You all can solve that for me, please. Oh, it is not. Liar. Liar! All right, do that for me, please. I'm waiting. We'll do it then. Quit talking and start talking. Well, what kind of a function is it? It's quadratic. You guys can solve quadratics in your sleep. He's right. Hate to admit it. So it's going to be what are these? Okay, that will end our vodcast. So Jacob, watch this.